All right, so after we talk about work, the next thing I want to talk about is mechanical energy. There are two kinds of mechanical energy. Okay, one is called potential energy. The other one is called kinetic energy. So let's talk about potential energy first. Okay, so potential energy actually is the stored energy um, with the potential to do work. Okay, so the most common potential energy in our class actually is called gravitational potential energy. But there are many different kinds of potential energy. Okay, so for instance, if the bow is drawn, so energy is stored in the bow can do work on the arrow, for instance. Okay, and so it's true as a rubber band, right? If you hold a rubber band and then you have a stone, wrapped around by the rubber band, once you release it, the stone is going to fly out. Okay. Also the spring, okay, if you have a spring, okay, and then the spring actually is able to store energy. Okay. There are some chemical energy in fuels, fossil fuels, and batteries. Those are chemical potential energy. But the potential energy we are going to talk about in this chapter is called gravitational potential energy, which is related to the height of the object. Okay, so what is potential energy? Okay, the potential energy is equal to the work done, okay, in lifting the object. So it is calculated by mass times gravity times the height. But how do we measure height? So that's the problem here. Okay, so we could, so if I have, this is the ground, I have a table here, okay, and I have an object here. So what is, or I could have an object here. How do we measure the height of the object? We could measure the height from here to here. We could measure the height from here to here. Okay, so that's why, when we talk about height, when we talk about potential energy, we need to ask ourselves, what is a reference point? Where do we start to measure your height? Okay, so if you're going to measure the height from the ground, then that's going to be your reference point, and then you measure all the height starting from the front, from the ground. If you want to use the tabletop as a reference, you can do that as well, but then you have to measure all the height from the tabletop. Okay, so that's one thing you need to pay attention to. Okay, the potential energy also has the unit for joules. Okay, so if you take a look at this example, okay, you have three different scenarios here. The same kind of ball, 10 newtons, okay, but these three cases, okay, these three balls, they all have the same potential energy. Why is that? Okay, so maybe I can lift the ball this way, I can lift the ball up the ramp this way, I can lift the ball up the stairs like that. But as long as, remember, the potential energy is defined as mgh. Has nothing to do with how you lift the object up to the certain height. It only depends on the height. Okay, so you can see here, if I lift the object from here to here, okay, this is my reference point now. And then the ball is here, okay, which is 3 meters up, okay, above the ground. So then when I calculate the potential energy, I just use mass, okay, mass, but mass times gravity is going to give you the weight, which is 10 newtons times 3 meters. That's going to give you 30 joules. Okay, so that's the potential energy. So these three objects, they have exact same potential energy. Okay, although they were lifted by different path. Okay, but for potential energy, we don't care about that. The next one is kinetic energy. Kinetic energy is something when something's moving, so then we define kinetic energy. So kinetic energy is defined as 1/2 mass velocity squared, or speed squared. Kinetic energy times 1/2 mv squared in joules. Okay. Again, kinetic energy, both kinetic energy, potential energy, they're all scalars, so you don't have to worry about directions. If the speed is doubled, we can see that, we talked about that before. If it doubled, the kinetic energy will be 4 times bigger than the initial cases. Okay, but as I said, you know, work, energy, they're not exact same thing, but they are sort of related. Okay, so there is a theorem we call kinetic work energy theorem. So the work, actually kinetic energy and the work of a moving object. So if we look at this equation here, the work done actually equals 1/2 the changing in kinetic energy. So I would just, I wanted to take a look at this slide. Okay, so the work equals changing in kinetic energy. So that means, okay, if the kinetic energy is changed, okay, whether it's gaining kinetic energy or reducing kinetic energy, but it's because the work done by the forces, okay, by all the forces. Here the work is actually net work done by all the forces. So again, here, if you think about the examples, the examples to calculate the work. If something is doing positive work on the object, okay, then it's going to help to gain the kinetic energy. If something is doing a negative work on the object, it's going to reduce the kinetic energy of the object. So that's, you know, in summary, we can summarize everything through this work energy theorem. Okay, so this is the topic I'm going to talk about next time. Okay, so then for today's lesson, I would like to ask you to do some of the worksheet problems. You know, I specified very clearly through the announcement, so please take a look at it, and then you guys can practice on what we learned today. And also, I posted some Khan Academy videos. You can choose appropriate topic to watch the video as well.